Ladies and gentlemen, it's a pleasure for me to be here. My name is Johann KRAXENBERGER. I'm coming from Germany, from Bavaria. That's why I have a little bit of accent. I'm based in Schrobenhausen and traveling, let's say, all over the world. I'm since 1993 in the BAUER company in different functions, and since 15 years now head of the product management. We're looking at deep foundation about the Secant pile walls. And first I want to have a look at the differentiation. What is in our thing multi-pass and single pass. And then we go to the single pass method, the CCFA. Very quick method, but with some restrictions and with some precautions in preparation of the whole job site. So, from the classification in multi-pass, everybody knows the Kelly drilling. We have big drilling depths up to 130 meter. A record for well drilling in Germany was 146 meter. Diameters up to 3.5 meters, or let's say most common 2 meter, 2.5 meter. We have a big variability in the tools and in the Kelly drilling method itself, either slurry supported with the depths, as I said before, above 100 meter. Once it comes to the case drilling, we are limited to the torque of the rig to install the casing. That's why we introduced the BTM, the BAUER torque multiplier, which gives us more torque to set the casing. And for really deep casing work, we have the oscillator, the BB. And on the bottom, you see, for the Kelly drilling, we have approximately 75 linear meter of productivity per shift. Once it comes to the oscillator, the productivity drops around 40 linear meter. Looking to the single pass methods, which is CFA, FDP, and we are looking at CCFA, the cased continuous flight auger system. It's a higher performance. If you look 75 linear meter compared to 150, 300 linear meter. For FDP and lost bit, FDP lost bit with the smaller diameters, we had productivities of well above 500 linear meter. For the case CFA with the continuous flight auger with casing outside, the common system is they're using the rotary drive, and below the rotary drive there is a torque multiplier which gives us a revolving direction counter-rotating to the auger. Here we have automatic systems to ensure the quality of the pile. You have a permanent constant quality, but you need really a high level of advanced job site logistic of concrete quality. It's different concrete to Kelly pile and also to the reinforcement design. So later on we will see how important it is to have a really good logistic system. So for the cased continuous flight auger, here a picture with the rotary drive, the torque multiplier, the material jute, and the drill string itself. Important is also to have a really straight drill string. You always have tolerances in the manufacturing. So sometimes it's really recommendable to look at your casings you have and choose the really good casing settings to have a really continuous good drill string. So in the working principle, we have the auger, which is transporting the soil. We have the casing outside. We have a really good verticality because of the stiffness of the drill string compared to CFA methods. Diameter range is from the smaller diameters, 400, 650, up to 1180. Then it comes to a limit of the torque of the rotary drive and the casing lengths to overcome the friction. A rock up to 20 MPa is also possible. The rock socketing, important is no boulders. We had job sites where they had cobbles, but the auger was heavy wearing and you have a shape of the auger which you can throw away then later on the auger. The depths with the bigger machines up to 28 meters is possible for foundations or for pile walls, secant pile walls. The procedure of the case CFA, we have the rig fully assembled. The red line is the concrete line, so we pump the concrete on top of the auger, which comes down directly at the bottom of the pile. We drill to final depth, where the material is excavated, transported with the auger upwards and thrown down with a tube. We have the concreting during the lifting, and afterwards the pile itself is finished with concrete, but the auger string is fully with material. That's why you have to empty the auger string. And the last working step is the installation of the reinforcement cage, either by crane or by backhoe, depending on the size and the dimension of the cage. We have a distinction between the CCFA system with 2 rotary drives, which is mainly used on the left-hand picture, mainly used direct to buildings, because the design of the rotary drive is in a way that we lose as less as possible space to get as much possible to the neighborhood wall. For the bigger diameter, the common system is the BTM system with diameters 1180 or 880, 900. The secant pile walls, so this is how it should look like after the result. We have the sheet pile walls, we have the diaphragm walls with bigger drilling depths or bigger wall depths, and the secant pile wall, which we are producing with the CCFA. Left picture, perfect wall. Right picture is a distinction with 2 methods, with 2 single pass methods. The left, on the right-hand picture, the left side was built by a CFA without the casing support. The right-hand picture is CCFA, and you see the difference in the pile quality. Characteristics of a secant pile wall. Excavations have to be or can be done next to the building. We are limited in depth. So secant pile walls, even if you do it in Kelly methods, around 35, 40 meter, depending on the rig type and on the verticality. So verticality, we can have up to a precision from 0.5%. Next to building, it is important to have as less vibrations as possible, and the secant pile wall allows also irregular geometric. For the overcut, the left and right are the primary piles here in this show, in this picture. It's cutted by the casing, and the auger excavates the soil in between for the secondary pile. The auger can be advanced or retracted depending on the soil condition. If you have a critical soil, the auger has to stay inside the casing. Guide wall you need. For the guide wall, reusable steel frame. Steel templates are a very good option for it. The guide wall after establishing is refilled and you have the best pile position. Quality assurance is important. Concrete is important. You need to have the concrete with more cement value, with retarders for a longer procedure time, and also the cage has to be a little bit different to the standard Kelly cage. Since you're vibrating the cage in, you have to have caliber rings to get the shape of the cage. The drilling assistant, we have assistant systems for the drilling to release the operator to have the correct ground speed and the correct RPM to excavate the soil. And more important even that is we have a concreting system which assures the constant quality. So you have the amount of the concrete volume from the concrete pump. You have the strokes of the concrete pump. Then you calculate the volume, total volume of the delivered concrete. And due to this, the pull speed is adjusted by the rig itself. So the result is really an independent of the operator, constant high pile quality. So now, interesting point, if you compare it to Kelly drilling, what is the benefit? If we have the limits, if we stay within the limits, the diameter and depth, we compare the Kelly method and the CCFA method. So if you compare the equipment, you have the drilling rig, you have the tools, you have a wheel loader, yeah, you have three staff on the job site. For the CCFA method, you have more equipment, you need the torque multiplier, of course you need the tools, you need also the wheel loader or a backhoe, then the concrete pump comes, the vibrator for the cage, a lifting crane for cage installation, if you need it. If not, you have with the crane operator at least one person more on the job site. But it's an example. Please use the figures as an indication and not as given values. And the figures is from faraway job site 5-10 years ago in Germany. Here, I think it's different, but the relation should be the same. For the Kelly method, we have a shift cost of the rig and the personnel without material, without concrete, without cage installation, of around 6,000 euro. The performance per shift, as we have seen before, 75 linear meter. The CCFA method, due to more equipment, due to more personnel, we have 9,000 euro. But at least we have 150 linear meter. If everything works together in gear, all the concrete supply, up to 250 linear meter are possible. If you look at a pile diameter of 900 millimeter and a depth of 20 meter, and a small pile wall, 150 piles, you finish it in 40 days. Because for the Kelly method, you have 3.7 piles a day. The total shift cost without material, 240,000. For the CCFA method, we have 7.5 piles or even 12 piles a day. So we have only the cost of 180 or only 108,000, so something in between. So we have 2 to 3 times faster job site finishing and approximately 30 to 50% cheaper. But everything has to be in gear, we say later on. And this is really important. Maybe we have a look at the graph. On the left-hand side is the depth. So the pile depth is around 15, 18 meter. The yellow line is the depth, and the upper black line is the rotary speed. So here we start the drilling goes down, and from here we start the concreting. Here you see directly the emptying of the auger because we are above zero, above the platform level, and then comes a big time frame doing nothing. And if you look at the right-hand side, also drilling, concreting, excavating, then a time doing nothing, and then finishing. And what could be this time frame? I don't know it because we can only see the machine data and not the production data, but I know it, what is the reason. We have 10 minutes for drilling, we have 10 minutes for concreting. So the pile is finished in 20 minutes. But then we have 30 minutes downtime. And what is the reason? Concrete supply. And also on the right-hand side, during concreting, the most possible reason there why there is a flat line is concrete supply. So this is very, very important. So in principle, you could double the performance, but this is depending on not on the job site itself, not on the drilling, it's on the logistic. Here, a short time-lapse video from YouTube. It was 2018 from YouTube, where it really shows if the job site is well prepared, how fast it can be done. So the drilling, the material comes out, concreting. You have the concrete, then the emptying of the auger. And this, now it comes a very, very good sequence. So they clean everything. And the backhoe itself catches the cage installation, done while the rig is drilling. So it gives you a really high pile numbers in one shift. And since it is a very common method where you can use it, here are some job sites references. We have in France, we have a rig doing 880 Secant pile walls. We have in Italy a retaining wall with a BG. Also retaining wall front of wall. There is a double rotary drive next to the building. And also it can be done not only with a drilling rig, but also with a RG rig. Here an example in Munich, small diameter, 610, 10-meter depth. And also here in Dubai, rigs are working with 880 diameter, 20-meter depth, and also Ras Al Khaimah with a retaining wall, 1,000 millimeter diameter, 18-meter depth. The presentation was done also in combination with my colleagues of the engineering department, of the method engineering department. And I want to invite you later on to the booth to have final discussions, to have more detailed discussions. Thank you.